welcome to Math 1400, Nunez Community College. This is going to be P Prerequisite 6, which is going to be functions and analyzing the graphs. I have three graphs that I drew up here, and they want us to find several things. They want us to analyze the graph at specific numbers. They want us to find its domain and its range. Now, the domain, remember, is a set of numbers where the x value cannot be repeated. So, in this, the domain wants to be all the x numbers from the smallest to the largest. So we always look at the graph from the left to the right, left being the smaller numbers. In this case, we start out with the x value being -1. That is the least number x that we can find. So the domain will be from -1, and it will continue on all the way until it gets to the end, which is 5. So the domain is going to be -1 to 5, written as an ordered pair. But the -1 has a closed dot, so it's included. If something is included, we put a bracket. Whereas we get to the 5, and the 5 has an open dot, which means it gets all the way up to 5, but not including the 5. So if it's not included, it's going to be a parentheses. So the domain is going to be from the number -1 to the number 5, including the -1, but not including the 5. For the range, on the other hand, we're looking at the y values. Again, it's from the smallest to the largest. The smallest to the largest. So we're looking at the y's up and down. The lowest point on this graph I see is right here, and this is represented with the y value -3. So it is from -3, and then moving up, moving up, moving up. There is no place higher than +3. So from -3 to 3 is the range. Now, the -3 is included. It goes down and it touches -3, so that will be a bracket, and the 3 is included, so therefore this will also be a bracket. So the range of this one will be -3 to 3, including both of them, so it will be brackets, just in the domain was -1 to 5, including -1, but not including the 5. When evaluating the functions, we look at the x value being this number, and we want to know what is the functional value. So at x being -1, the function, which is going to be our y value, is at 1. When we look at x being 2, our functional value being 2, we look at where the x is 2, and our function itself is at -3. That is the functional value. And at 3, 1, 2, 3, we look at the function being right here, which should be at -1. And this is finding its domain, its range, and functional values at specific points. When we move over to the second one, we have a little something different. Our domain, again, is the x's. Our least x is over here at what? -1. And then we're going to where? Coming all the way over. This does not stop. It goes off of the bottom of your graph, which means we're going to assume it continues forever and ever. And yes, it's going down forever and ever, but it keeps on going more and more and more to the right. So it's going to be from -1 all the way to infinity. Infinity being a sideways 8, meaning it goes on forever and ever and ever. We starting at -1, it's a closed dot, so it's going to be a bracket. Infinity, we can never get there because we can always add more numbers to it, so infinity always has a parentheses. The range, well, we're going to start out with the lowest point. Well, if it keeps on going down forever, that means we're starting out with the lowest number we can think of, which is going to be -infinity. And we're going to come up higher and higher and higher until we get to the top. This is the highest point we can find, and this is 1, 2, 3, 4, 5, 6. So from -infinity to 6. Just like infinity, we never get there. Negative infinity, we never get there. So we always have a parenthesis around the infinities. And the 6 is included, so that will be a bracket. For the actual functional values, we look at -1. At -1, we can count and we get to what? 4. So at -1, the function is valued at 4. At 2, we go to here, the function is at 6. So the function is valued at 6 when we're at 2 on the x-axis. And then the number, our x is 3. At 3, the function is passing through the x-axis, which represents 0 on the y's. Example number 3. What happens if we have a graph that looks like this that's broken? Well, the domain is going to be from this, which is going off the screen. It's going off the screen. It starts at what? Negative infinity. And it's going. As it gets to the number 1, it's included here. But as it gets past the number 1, it jumps down to here. However, since this is solid and that is an open dot, it does not interrupt. It keeps on going, like as if it was all connected on the x's. So from here to here would be from negative infinity to positive infinity. Again, parenthesis, parenthesis. The range is going to be the y's. We're starting at its lowest point. Well, this goes off up. This is going up. It starts right here. This is at what? -2 is the lowest point you can find. And going up, since it goes off the screen, goes to infinity. The -2 is not included because it's an open dot. So that would be a parenthesis. Infinity always has a parenthesis. When we look at the functional values at 1, it's right here, not here, because this is the closed dot, that's the open dot. We include it right here. At 1, the function is 0. And at 2, the function is also 0. So that's looking at the domain and the range, looking at a function and finding its functional values. Now there is one more thing. We need to know how to tell if a function is a function if it's a graph. And we can tell that by doing something called a vertical line test. A vertical line test. That allows us to tell whether or not a graph is a function. The vertical line test can only hit a function, no matter where you put it. It can only hit a function in one spot. If it hits it more than once, it is not a function. So I can draw vertical lines down this one here. No matter where I draw the vertical lines, I'm only hitting the function in one spot. So therefore, this is a function. The same thing here. I can draw as many vertical lines as I want, even right here at 1. Remember, that doesn't count, so it's only hitting it once. So yes, that is a function. What does it look like if it's not a function? Well, suppose I have one that looks like this. If I draw a vertical line, I hit it once, I hit it twice, which means what? The x value repeats. So this would not be a function. Anything I draw, even if it can only hit it in a certain spot, something like this. I'm only hitting it once, but if there's any place I can draw and hit it more than once, then it's not a function. And finally, suppose I had something that was like a circle. Again, hitting it more than once no matter where I go, so it is also not a function. This is Section 6, or P6, Math 1400, and that was analyzing graphs of functions. See you at the next one.